Hello, everyone. Welcome to the first episode of our Python Performance Optimization Tips series. I'm your host, Quinn, and together we'll explore some essential techniques to enhance the performance of your Python code. Let's get started. In this session, we'll cover the fundamentals of performance optimization in Python. We'll discuss common bottlenecks that might slow down your code and then dive into practical techniques to improve it. By the end of this tutorial, you'll have a solid understanding of how to optimize your Python applications for better speed and efficiency. Performance optimization is crucial for any Python application, especially those dealing with large datasets or complex computations. This process helps in making your code run faster and more efficiently. We often need to optimize performance when working on data science projects, web applications, or real-time systems where speed can be a critical factor. Python has several common bottlenecks that can slow down your code. Loops are often inefficient, especially when dealing with large datasets or complex calculations. Inefficient algorithms can also significantly impact performance. Additionally, the global interpreter lock GIL in Python can be a bottleneck for multi-threaded applications. To optimize your Python code, you need to first understand where the bottlenecks are. Profilers like cprofile can help you identify slow parts of your application. Once identified, you can then use benchmarks to measure performance improvements after implementing optimizations. Let's look at an example of how to use the cprofile module. Here, we have a simple function that generates random numbers and sums them up. By running this code with cprofile, we can get detailed profiling data about which parts of our function are taking the most time. Choosing the right data structure can significantly improve your code's efficiency. For example, using sets or dictionaries instead of lists can greatly speed up certain operations like membership testing and lookups. Additionally, refactoring algorithms to be more efficient is key in reducing runtime. Caching is a powerful technique that can help reduce the computational load by storing the results of expensive function calls and reusing them when the same inputs occur again. This can be particularly useful in scenarios where certain calculations are repeated multiple times. Here's a practical example using the functools.ru_cache decorator. This function simulates an expensive operation and returns twice the input value. By caching the results, we can avoid redundant computations if this function is called with the same argument multiple times. For certain applications, especially those dealing with I/O-bound tasks or CPU-bound processes, utilizing multithreading and multiprocessing can significantly improve performance. Threading is great for handling multiple I/O operations simultaneously, while multiprocessing allows you to leverage multiple CPUs by running functions in separate processes. Python comes with a plethora of built-in libraries that can help optimize your code. For example, NumPy and Pandas are excellent choices for numerical computations and data analysis. Additionally, third-party tools like PyPy or Number can offer significant performance improvements in certain scenarios. After implementing optimizations, it's crucial to review your code again. Profiling tools can help you identify remaining bottlenecks and guide further iterations of your optimization process. In this session, we've explored various techniques to optimize Python performance. We discussed common bottlenecks and introduced methods like profiling, choosing efficient data structures, caching results, using multithreading and multiprocessing, leveraging libraries, and iterative code review. To further your learning, I encourage you to practice these optimization techniques in real-world scenarios. Additionally, exploring other resources such as online tutorials, books, and community forums can provide even more insights into performance optimization. Thank you for joining me today. I hope you found this session valuable. If you have any questions or need further assistance, feel free to reach out. Stay tuned for more Python tutorials and other exciting content here on Elevate Learn.